Unit circle, part 2. All right, so in the previous video, we discussed the unit circle and filled in this table a little bit. So I'm going to do a quick recap on that, fill in some of this information, the pattern on here. Now, you can type in your calculator and get a lot of this stuff. Remember, the 0.866 decimal refers to the rad 3 over 2, and the 0.707 decimal refers to the rad 2 over 2. But you could actually fill in this table a lot, especially these first group right here, just from the pattern, knowing that sine increases from 0 to 90 and cosine decreases. So sine 30 is 1/2, and that's like rad 1 over 2. So this is rad 2 over 2, and this is rad 3 over 2. So sine goes up. Rad 1 over 2, rad 2 over 2, rad 3 over 2. I'm not going to write it as rad 1 over 2 just because we know the square root of 1 is 1. But remembering that pattern, it makes it really easy to remember these values for sine. For cosine, and then sine 90 is 1. Because sine's increasing from 0 to 1. So this is 0.5, 0.7, 0.8, and 1. So it goes up. Rad 1 over 2, rad 2 over 2, rad 3 over 2 to 1. Cosine's the opposite. Cosine is going to go rad 3 over 2 to rad 2 over 2. And one thing about the 45, and we've talked about this, is that at 45, sine and cosine are the same, because if you have a 45-degree angle in a right triangle, the other angle is also 45, which means it's isosceles, which means that the opposite and the adjacent are the same, which means that x and y are the same. So at 45, it's easy to remember that they are the same. Cosine 60 is the 1/2, so it's the reverse of the sine. Sine goes rad 1 over 2, rad 2 over 2, rad 3 over 2. Cosine goes rad 3 over 2, rad 2 over 2, 1 over 2. But again, remembering what decimals are and stuff like that, you could just simply type cos 30 and say, oh, I recognize that. That's rad 3 over 2. So you don't necessarily need to memorize, but you certainly could. And then this is 0. Why is it 0? Well, remember, and I mentioned this in the previous video too, that on the unit circle, this is the point 1, 0. This is the point 0, 1. Just think coordinates. What would the coordinate be if you, from the origin, went up 1? Your x is 0 and your y is 1. This is the point -1, 0. And this is the point 0, -1. And then, something I told you to get in the habit of is for unit circle coordinates, put a CS on top of it. CS, 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 CS. So here's your 90-degree angle stuff right here. And at 90 degrees, sine is 1, cos is 0, as we filled in here. At 180 degrees, sine is 0, cosine is -1. At 270 degrees, sine is -1, cosine is 0. And at the 360 degrees, which is also the same thing we know as 0 degrees, sine is 0 and cosine is 1. But again, simply type into your calculator cosine 270, it's going to tell you 0. If we ever need tangent, we do sine divided by cosine. All right, so let's get to a couple of problems here. One last thing I want to add to this picture that's going to be useful is remembering all this stuff, but the keys here are to remember that x comma y corresponds to, like I've already said, cosine comma sine. Remembering that's going to be huge. And then there's also going to be a lot of reference angle things here. So let me put those rules up here again. Remember, in quadrant 2 and 3, your reference angle, or reference angles in general, are distance to 180. So the rule in quadrant 2 is how short of 180 are you, is the angle. And the way to do that math, if you can't do it in your head, is 180 minus your angle. So in quadrant 2, your distance to the x-axis is your distance to 180, and 180 minus your angle tells you that. In quadrant 3, the distance to the x-axis is also the distance to 180, but you have to do your angle minus 180 because you're past 180. In quadrant 4, your distance to the x-axis is not the distance to 180, it's the distance to the 360. So how short of 360 is your angle? 360 minus your angle gets you that information. So reference angles, x cos y sine, exact value table, that's what's going to help us today. So in the accompanying diagram on the unit circle, on the unit circle, the ordered pair xy represents a point, terminal side theta, Angle theta is 120 degrees. What is the value of x in simplest form? Angle theta is 120 degrees, x. When you see x, you need to think cosine. So when they're asking for x, they're asking for cosine theta. Theta is 120 degrees. So what we're really doing here is cosine 120. You don't need your calculator. First, let me show you with the calculator that cos 120 is negative 0.5. So our answer is negative 1/2. And ultimately, that's all you need to do. The reason why it's negative 1/2, again, it's in quadrant 2. 120 degree angle is how far from 180? It is 60 degrees from 180. So 120 degrees is a reference of 60. And so we'll go back to our table. We're talking about this column right here. Then, because we're talking about x, we're talking about cosine. So we're really talking about this value right here. But is it positive or negative? Quadrant 2, with our ASTC, we know that sine's positive here, but cosine is negative. Plus, just think about the x value. Any coordinate here is going to be negative x comma y, right? This is a negative x axis right here. So that's why it's a negative value right there. So there's a lot of ways to kind of think about this, but asking for x at an angle is asking for cosine of that angle. So this was a case where they're giving us the angle and asking for x and y. Let me real quick, the problem didn't ask for it here, but what is the y value? Well, the y value of the coordinate at 120 is the sine value of the coordinate at 120. And our y value is positive in this quadrant. Sine is positive in this quadrant for the same reason y is positive in the quadrant, because it's the positive side of the x-axis. And this is a reference of 60, and sine 60 is radical 3 over 2. The table tells me that here. Sine 60 is radical 3 over 2. But this time it's a positive because sine's positive in this quadrant, but cosine is negative in this quadrant. All right, so that was given an angle and wanting, part of the coordinate here. Here they're giving us the coordinates. They want to know what is the angle. Now, first thing, and I've said this many times, that the most important thing in trigonometry is location, 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 just like real estate. You are in quadrant 3. So make sure your angle's in quadrant 3. Now, all of these are. But I've seen problems like this where they had this type of thing, and then they had answers like 60 and 330. Those don't make any sense. You know your angle's in quadrant 3. You're going to use a reference angle to help you, but always remember we're looking for an angle in quadrant 3. It's between 180 and 270. Take a look at this value. Negative rad 3 over 2, comma, negative 1/2. Always put CS on top of your unit circle coordinates. Cosine's negative rad 3 over 2. Sine is 1/2. When is sine the half and cos the rad 3 over 2? So we're looking for sine half cos rad 3 over 2. Sine half cos rad 3 over 2 right here. Sine's a half at the 30 mark. Cosine's rad 3 over 2 at the 30 mark. So what that means, because my sine value is a half, that means we're looking at a reference of the 30-degree angle. Clearly, the answer is not 30 degrees. That means we're 30 degrees from the x-axis. We're 30 degrees past the x-axis in quadrant 3. And 30 past 180 is 210. It's easy to check these too, because once you think the answer is 210, if you type in sine 210, you're going to get this. If you type in cos 210, you're going to get this. Let's see that real quick. Sine 210 gives me my y value, negative 1/2. Cos 210 gives me my x value, negative rad 3 over 2. So that's really what this is, and that's where we're going to stop. That if I'm giving an angle, I can get x and y by doing cosine if I want the x, sine if I want the y. And reference angles can help us understand why the answer is what it is. Always remember, is it positive or negative? Is the sign positive? Is the function positive or negative? Is the x and y values positive or negative in that location? Given a coordinate, You have to think, all right, when is cosine that ratio and when is sine that ratio? And you can do that in your calculator. We can do things like second sine, inverse sine, stuff like that. But you should just know that sine's the half at the 30. Um, if you see the cosine, the x value being a half, that's a 60 reference. When you see the rad 2 over 2's for both of them, you know it's a 45 reference. And then think that's distance to or from the x-axis and what that translates to.